Hi guys, today we're going to be looking at a heat and work problem. This is very similar to the ALEKS topic titled Understanding the Definitions of Heat and Work. So our question is, a mixture of gaseous reactants is put into a cylinder where a chemical reaction turns them into gaseous products. The cylinder has a piston that moves in or out as necessary to keep a constant pressure on the mixture of 1 atm. The cylinder is also submerged in a large insulated water bath. From previous experiments, this chemical reaction is known to release 386 kilojoules of energy. The temperature of the water bath is monitored, and it is determined from this data that 214 kilojoules of heat flows out of the system during the reaction. Our questions are: A. Is the reaction exothermic or endothermic? B. Does the temperature of the water bath go up or down? C. Does the piston move in or out? D. Does the gaseous mixture do work or is work done on it? And E. How much work is done on or by the gaseous mixture? Now we have quite a few questions here, so let's try to group them together and see the common topics that they have with each other. Question A is asking if it's exo or endothermic, and we know that we only use those terms when we're talking about heat. So question A is going to be about heat. And then question B says, does the temperature of water in the bath go up or down, which is also about heat. So let's tie those two together because they're both heat-related questions. Now let's look at C. Does the piston move in or out? Now that's going to determine on the work and if the system does work or if work is done on the system and how much work is done, which is pretty much question D and E, what they are asking. So let's tie those three together as questions about work. Okay, now let's go back to the overall problem. In the description that we're giving at the beginning, it does mention the system quite a few times, and we are doing a heat and work problem. So let's determine what our system is and what our surrounding is, just so we can understand the problem better. It's talking about these gaseous reactants inside this piston here, and that's going to be our system. And then this water bath outside are going to be our surroundings. So our system is the gas, and our surroundings are going to be this water bath. All right, now let's begin by working on our heat problem. So question 1 is asking, is the reaction exothermic or endothermic? Now in class we learned that if the system releases heat, it's going to be exothermic, and if the system absorbs heat, it's going to be endothermic. And from rereading our description, we see here that 214 kilojoules of heat flows out of the system. Since this heat is leaving the system, it's going to go into the surroundings. This is similar to releasing heat, so the answer to A is that our problem is exothermic. As I just mentioned, since this heat is flowing out of the system, it's going to go into the surroundings of the water bath, and it's going to gain this heat. So the temperature of the water bath will go up, which is our answer to question B. All right, now let's look at our work problems. We're asked, does the piston move in or out? Does the gas mixture do work or is work done on it? And how much work is done? I would suggest answering E first, because then we could answer these other two problems after we find how much work has been done. So we want to use that equation that we learned in class, delta E equals W plus Q. And this was our equation that we learned for the relationship of heat and work, where delta E stands for the change in energy, W stands for work, and Q stands for heat. So from our problem, in this description, it says, from previous experiments, the chemical reaction is known to release 386 kilojoules of energy. So here we're going to get our delta E. And down here where it talks about heat, we get our heat as well. So it's clear that we're solving for W, which is good because that's what we're looking for in these problems down here is we're looking for work. So we want to rewrite our equation to solve for work. So we're going to write W equals delta E minus Q. All right, and now we can plug in our numbers, but we need to check the signs of our numbers depending on if the system is releasing them or absorbing them. So we're going to write W equals, and we're going to look at delta T, And it says that the reaction is known to release 386 kilojoules of energy. So that number is going to be negative. So we're going to write negative 386 kilojoules. And before we do this, we want to make sure our units are the same. So our units in energy is kilojoules and our units in heat is kilojoules. So that's good. So we can subtract them because they're in the same units. Now let's look at Q. It says that heat flows out of the system, which means this number is also going to be negative. So we're subtracting negative 214 kilojoules. So again, we know that our units are the same so that we can subtract them. Now for W, you should get that it equals negative 172 when you plug that into your calculator. So we know that work is negative. So this negative 172 is actually our answer to E, if we want to put that back up here with our answers, and we are going to remember our units of kilojoules. And now let's go back and let's try to answer C and D. Since work is negative, it tells us that work is done by the system onto the piston. So that work is going to push onto that piston and move it out. So that answers C, our piston moves out. And that also answers D, because I just mentioned that when work is negative, the system does work. So the system does work. All right, and that answers all of our problems. So let's just summarize what we did. We got the description about how much energy was going in or was coming from the system. We looked at heat, and then we grouped our questions together into heat and work questions to determine how we were going to answer both of them. We used the context from the description to answer both of the heat problems, and then we used that equation delta E equals W plus Q to answer our work problems. All right, have a great day, guys.